Hello, Algebra 1B students, for Mr. Fry. Today is February 25th, and we're looking at the elimination method. I believe you did some of these in class. You should have done some of these in class. If not, I've got them here for you. And then I got some extra ones for in the future. You're going to do some more tomorrow, and at least I have every other one, or a few extra ones done, I should say. So taking a look at using the elimination method, actually, substitution would be better here, but we're going to do elimination method. So what I'm going to do is I'm going to get this to equal negative 3x, so I can get rid of the x's. Okay, there's, that's one way to do it. So then I have 10 on this side, and I'm left with negative 2y over here. 10 divided by negative 2 is going to be negative 5, so y is going to equal negative 5. I take that negative 5 and I plug it back into one of these problems. This one was the easiest one to do. Either one, you're going to get the same answer. So negative 5 equals x minus 2. I add 2 to both sides, and I get x equals negative 3. So my coordinates for the intersection of these two lines would be negative 3 and negative 5. That's my solution. For number 2, you can see that I ended up multiplying each term of this second linear equation here in standard form. I would multiply each term by 4 so that I have a positive 4y and a negative 4y. They would eliminate each other. That's why it's called the elimination method. So these eliminate each other. So I have 4 plus 1x, so I have 5x, and this equals 25. So 25 divided by 5, x equals 5. I put that 5 in for my x in one of the problems, and I chose this one was the easiest one. So to get the y all by itself, I subtracted 5 from both sides, and then I got rid of the negative from here, so I had to get rid of the negative from here. So my answer is going to be 5, 2. My x is 5 and my y is 2. This one, I just multiplied everything by a negative 1. So I got a negative 3x, this changed to a positive, this was a positive, so it changes to a negative. The reason why I did that, so I could use the elimination method. And then I'm going to have negative y equals negative 1 when I work this out. Multiply both sides by a negative 1, or you could think of it like I said in the previous problem. If I get rid of the negative on this side, I have to get rid of the negative on this side. And so I'm left with y equals 1. I plug that 1 in to one of the problems. I chose the bottom one just because it looked easier, I guess. And I end up getting my x as 8, and you can see the steps there. So my x is 8, my y is 1, so that's the coordinate for where those lines would intersect. That's the solution. This one, I multiplied everything by negative 1, all the terms by negative 1 down here, so that in essence just changes each sign. So this becomes a positive, this becomes a negative, this becomes a negative. Okay, so that way I can eliminate the 2y. And so I'm left with 6x equals negative 12. Negative 12 divided by 6 gives me x equals negative 2. I plug in that negative 2 for x value. I chose the first one, it just looked easier to me. I worked the problem out, isolating the variable. Y equals 7, and I get negative 2 and 7. And then number 5 was the last one that you were asked to do for today. I do have some other ones set up for you and for what we're going to be looking at tomorrow. A little bit of what we're going to look at tomorrow. I think the second page I didn't have anything done, so we'll see about that. So what I did, this is already set up. I have 4x and I have minus 4x, so these cancel out already. So 9 plus 7 is 16, 5 plus 11 is 16. 16 divided by 16 is 1, y equals 1. Now I'm going to plug that 1 in for y. So I plug the 1 in for y. Okay. This is x, that 4x. I put it in the first problem, just looked easier to do it that way. Isolate the x. You can see my steps here. x equals negative 1. So my answer is negative 1y. Remember, x always comes first, xy coordinate. I set up number 6 for you. This, I just multiplied everything by 5, so I can get rid of the 10s. And then you can go ahead and start figuring that out. For number 7, this one's already set up. The y's are in line. I have a negative y and a positive y, so this becomes 4x equals 28. 28 divided by 4 equals 7. I plug in 7 to the easiest problem. Either problem would work, you get the same answer. I get negative y equals 3. I don't want to know what negative y is, I want to know what y is. So I multiply both sides by negative 1 to get rid of that negative, and so y equals negative 3. So my xy is 7, negative 3. I skipped down and I started doing evens. I don't know why, but here you go. Number 8, well, I just had to rearrange it to line up this 3y and this negative 3y. So if I'm going to line it up that way, this x would come over here and it would be negative x. And then this 11 would come over here and it would be a negative 11. It would change the values of those. And then I just rearranged it so that they would line up with that in mind. So I'm here with my x's. So 2x minus x is going to be just an x. And a negative 11 and a 16 is going to be a 5. So I plug in that 5 into one of the problems. I plugged it into that first one. And then I solved for y, and I got negative 2. Number 10 is easy. Looking at these are actually the same problem, so there's going to be no solution. They're parallel lines. If you were to work these out into slope-intercept form, you would see that they have the same slope. Having the same slope means that they're never going to intersect. In fact, if you started to do this, if I changed all these signs, negative, positive, positive, if I changed all of them, so this would cancel out and this would cancel out, I would get just negative 10 equals 13. No, it does. Negative 10 does not equal 13. And there's no solution, meaning that they're just parallel lines. They're never going to intersect. So hopefully that helped you guys, and good luck with the rest. I think I've done all of them that are due for today, but tomorrow some of those other ones you'll be doing.